You think you know what temperature is. You've felt hot, you've felt cold. You've checked the thermometer 1,000 times. You've complained about the weather, turned up the heat, so you must understand it, right? Okay, explain it to me. What is temperature? What is heat? Not what it feels like, what it is. Most people say something like, it's how hot something is, which is not an answer. That's just saying the word twice with different letters. It's like explaining what blue is by saying it's the color of blue things. You haven't explained anything, you've just renamed the mystery and called it a day. Some people go further, it's energy. Okay, getting warmer, pun intended. But what kind of energy? Where is it? What's actually happening inside that cup of coffee that makes it hot? What's happening inside a block of ice that makes it cold? Most people, if they're honest, have no idea. They feel it, they measure it. They've never once stopped to ask what it actually is. And here's the thing that should bother you. Temperature isn't a substance. It isn't a fluid. It isn't even a property of an object the way mass is, or color, or shape. You can point to the mass of an object. You can measure its color with a spectrometer. But temperature? Temperature is something stranger, something more slippery, something that doesn't live in the object the way you think it does. When you touch something hot, you feel like heat is a thing, a real physical stuff that moves from the object into your hand. That feeling is wrong, completely, fundamentally wrong. And the fact that it feels so obvious, so intuitive, so clearly correct, is exactly why it's been misleading people for centuries. This is the misconception. Not a small one, not a technical one, a deep one. One that sits underneath everything you think you understand about warmth, cold, fever, fire, and ice. Let's pull it apart. For most of human history, smart people believed heat was a fluid, a real physical substance. They called it caloric, invisible, weightless, self-repelling. It flowed from hot objects into cold ones the way water flows downhill. You put your cold hand near a fire and caloric poured into it. You touched ice and caloric drained out. And it explained things well enough. Boiling, melting, expansion. Scientists built entire theories around it, respected ones, published in serious journals. And it was completely, utterly wrong. Here's the experiment that killed it. A cannon barrel being bored, metal being drilled, scraped, ground down. The barrel got hot, very hot, so hot you could boil water with it. According to caloric theory, the heat had to come from somewhere. The caloric had to flow out of the metal as it was cut. But the heat never stopped. As long as you kept drilling, it kept getting hotter, indefinitely. Where was all this caloric coming from? The metal wasn't running out of anything. It was just sitting there, being rubbed, producing heat forever. Caloric couldn't explain it, but motion could. Heat isn't a fluid, heat is motion. That's it, that's the whole answer. Atoms moving, vibrating, bouncing off each other. The faster they move, the hotter the object. The slower they move, the colder. There is no substance flowing. There is no invisible fluid. There are just particles moving. Try it right now. Rub your hands together, fast, really fast. Feel that warmth spreading across your palms. You just made heat, not summoned it, not released it from storage somewhere. You made it. You took motion, the mechanical movement of your hands, and converted it directly into what we call heat. No caloric involved, no mysterious fluid, just friction, just motion, just atoms in your skin bouncing faster than they were 30 seconds ago. And here's the part that will actually break your brain. Cold isn't a thing. There is no cold. I mean that, there is no cold. Cold is just less motion. When something feels cold, it's because its atoms are moving slower. And when you touch it, they slow your atoms down too. Cold doesn't enter your hand, heat leaves it. Cold is an absence, a direction, not a substance, not a force, not a thing. Just the lower end of a scale that measures one thing only, how fast the atoms are moving. So if heat is motion, what is temperature actually measuring? Because they're not the same thing. Most people use the words interchangeably. They shouldn't. Heat is the total energy of all that motion. Temperature is something more specific. Temperature is the average kinetic energy of the particles, the average, and that one word changes everything. Here's why. In any object, a rock, a glass of water, the air in this room, the atoms are not all moving at the same speed. Some are flying, some are crawling, some are bouncing hard off their neighbors, some are barely drifting. It's chaos in there. A complete statistical mess of particles all moving at wildly different speeds in wildly different directions. Temperature doesn't measure any individual particle. It measures the middle of that chaos, the average. If the average goes up, the temperature goes up. If the average goes down, the temperature drops. Simple. Except the reality hiding underneath that simplicity is anything but. Think about the air around you right now. It feels still. Maybe a little warm, maybe a little cool, calm. But the molecules in that air are moving at roughly 500 meters per second. Every single one of them. Flying, colliding, bouncing off the walls, off the ceiling, off your skin, billions of times per second. That sensation of warmth on your arm isn't coming from something passive. You are being bombarded, constantly, by invisible particles moving faster than a fighter jet. That's what warmth is. That's what you're actually feeling. Remember the plastic wrap experiment from the electricity script? You rubbed plastic between your hands, held it near your skin, felt your arm hairs reach toward it. You were feeling electromagnetic force acting at a distance, and it seemed almost magical. This is the same thing. What feels like a calm, gentle warmth on your skin is actually trillions of molecular collisions per second, transferring kinetic energy directly into your body. The calm is an illusion. Underneath every sensation of temperature is a storm of motion so fast, so relentless, so incomprehensibly dense that if you could see it, it would look nothing like what you feel. Temperature is just the number we put on that storm, the average speed of the chaos, nothing more. Now here's where it gets strange. If heat is motion and cold is just less motion, you can ask the obvious question. What happens if you remove all the motion? Every last bit. What's at the bottom of the scale? The answer is absolute zero, minus 273.15 degrees Celsius. The point where atoms stop moving entirely. No vibration, no bouncing, no flying, no crawling, nothing. Complete stillness. The coldest anything can ever be, anywhere in the universe, ever, and you cannot reach it. Nobody can, nothing can, ever. This isn't an engineering problem. It's not that our refrigerators aren't good enough or our technology isn't advanced enough. It's that the universe itself won't allow it. The closer you get to absolute zero, the harder it becomes to extract that last remaining motion. You can cool something to a fraction of a degree above it, a thousandth of a degree, a millionth. Scientists have gotten extraordinarily close, but that final step, closing the gap completely, is permanently structurally impossible. Sound familiar? It should. The speed of light, nothing with mass can reach it. You can get close, very close, 99.9999% close. But the last step costs infinite energy. The universe has two great unreachable limits, one at the top of the speed scale, one at the bottom of the temperature scale. Both are walls built into the structure of reality itself. Both tell you something deep about the nature of the universe, and both are impossible to breach for the same underlying reason: quantum mechanics. Here's the twist. Even if you somehow drained almost all the motion from a system, quantum mechanics would stop you at the last moment. The Heisenberg uncertainty principle says you cannot know both the position and the momentum of a particle perfectly at the same time, which means a particle can never be perfectly still. If it were still, you'd know exactly where it was and exactly how fast it was moving. Zero. And that's forbidden. So particles always retain some irreducible jitter, a tiny quantum tremor that can never be removed, never be cooled away, never be silenced. The universe refuses to hold completely still. Even at the bottom, there is motion. Even in the deepest cold imaginable, something is always moving. That's not a flaw in our measurements. That's reality. That's the floor. Here's the thing nobody tells you. You have never felt the temperature of anything in your entire life. Not once, not even close. Every time you've touched something and thought, that's cold or that's warm, you weren't detecting temperature, you were detecting heat transfer. The rate at which energy was moving between the object and your hand. That's it. That's all your skin can feel. Not temperature itself, the movement of heat, the direction and speed of it. That's your entire thermal experience of reality. Here's the proof. Take a piece of metal and a piece of wood. Leave them both in the same room overnight. Same room, same air, same temperature. In the morning, touch them both. The metal feels cold. The wood feels neutral, maybe even warm. Same temperature, completely different sensation. How? Because metal conducts heat away from your hand much faster than wood does. The moment you touch the metal, it starts pulling energy out of your skin, rapidly, efficiently, aggressively. Your hand interprets that rapid loss as cold. The wood pulls heat slowly. Your hand barely notices. Same temperature, opposite feelings. Your entire perception was wrong both times. Think about what that means. Every time you've been cold, every time you've been warm, every fever, every hot shower, every freezing morning, every sun-warmed seat on a summer afternoon, none of it was you detecting temperature directly. All of it was your body sensing the flow of energy in or out of itself. You've been measuring the current, not the level, the transfer, not the state. Your thermometer is broken. It always has been, and you never noticed. Now zoom out, all the way out. Everything you have ever experienced as heat or cold, every sensation of warmth, every shiver, every moment of comfort or misery, it's all just atoms moving. Your body is a collection of atoms in motion. The world around you is atoms in motion. When you feel warm, nearby atoms are crashing into yours and speeding them up. When you feel cold, yours are crashing into slower ones and losing speed. That's the entire story. That's the full explanation. Atoms moving, colliding, exchanging speed across every surface, every moment, every experience you've ever had. The chill of a winter morning, the warmth of a fire, a child's fever, the heat of the sun across 93 million miles of empty space. All of it, nothing but motion. Particles bouncing, energy transferring. The universe doing the only thing it knows how to do, moving. And the fact that you can understand that you can sit here, a collection of moving atoms, and figure out that you are a collection of moving atoms. That your curiosity, your confusion, your sense of wonder are themselves just extraordinarily complex patterns of motion in a universe made entirely of motion. That's not nothing, that's everything. Not comfort, truth.